Good afternoon, colleagues. I hope you can hear me well. I'm Ludmila. Here I represent the joint stock company Russo. We are part of Rosatom Corporation. I would like to speak about a more difficult topic, which is the cybersecurity of process control systems of atomic power plants, nuclear power plants. We'll speak about problems and explain how we develop this trend and which cyber test site we construct. We'll start about process control systems in nuclear power plants. We are a company which is, of course, a supplier of process control systems. So we are the executor of the head customer, also providing all of the orders on security parameters, and we develop all of the software for electrical systems. We provide software for them. Requirements for security still stand, but we are also a customer because process control system is a very complicated environment. So in our supply chain, we have more than 50 suppliers, so we have to translate proper requirements, do proper tests, and implement proper systems. So security systems, the process control systems is complicated. So we normally treat this as normal automation, but we have a lot more systems there. We have the unit system, we have the overall system. They are all divided into data processing, automation, and the top level is the monitoring level, the monitoring of the processes. Each of them can be called a system, a subsystem, whatever you call it. For simplicity, would be mentioning the subsystem, but here we mean that there should be a huge set of machinery and equipment. It manages the facility, and it collects information from the neighboring systems and exchanges the data with outer systems, so the enterprise itself of the nuclear power plant and with the systems of the regulators. So the first thing we just need to mention is the factors. There are different factors, security factors that somehow affect the construction of their systems and creation of the security systems. We have such factors on the screen. First of all, there is a priority of the nuclear and radiation safety. We would always have to follow the nuclear and radiation safety rules. Any decision we take should be aligned with the scientific research surveillance body, and only after their approval we can take any measure. Any measure we take, whether it's an outer one or an embedded one, whether it's just the settings of the application, should have zero impact on the technology process of the nuclear power plant. It's different each time in terms of its importance. It's evaluated at different stages, the test stage and then the operation stage. Our system is not isolated, however. It cannot be isolated because it interacts somehow here and there with the other neighboring systems that the nuclear power plant has. A simple example. For example, we have the radiation control system, which does not belong to process control system of the plant, but it sends us data which we need at work. This should be taken into account for safety measures as well. We also send this data to corporate systems. This is the system which serves this station, process control systems, through which we correspond with regulators and other bodies. All these things should be taken into account because the perimeter protection is one of the cornerstones of any security system. There may be some complications because our supply chain is huge, it's very complex. Sometimes we make just 4 blocks, 4 units at the station, so therefore the manufacturers account for 80 or even higher, and there are different manufacturers with different algorithms, with different principles of work. We also have the international atomic regulation requirements, and we have them all on very rigid logic. We also have, on the one hand, a very good aspect of security. We have our own proprietary homegrown solutions. A lot of the vendors somehow try to make their technology safe by doing so. On the one hand, it's a good solution because the fewer the violators, the less the chance that they will ever try to disassemble the system. On the other hand, without actually knowing what this protocol may be like and whether there is a hidden channel, we will not detect any intrusion. The intrusion will just identify the presence of the protocol, but if there is no such thing, there will be nothing like that. But if we speak about industrial protocols and filtering, so there will be an open port and there will be no use from that. It's one of the questions that we keep on having. The software we have a proprietary system, a license product, but we have our own software in the embedded modules. So all these things should also be taken into consideration. And the last thing is the limited access of the measures of protections, because there may be a lot of them available in the market, but they either are targeted at the corporate segment or in principle they do not take into account our technological process and they cannot be applied there. So we work with vendors. They should be adapted and should develop our specifics.
Есть вообще, можно рассказать об идеальной истории, как мы видим строить
what would be the perfect story?
Вообще систему информационной безопасности на станции. Но есть и жизнь.
For the nuclear power plant.
Они достаточно новые, особенно в масштабах стройки станции, когда у нас там только контракт, от начала заключения контракта до, наверное, пуска блока может пройти там не один десяток лет.
We can start it in a few dozens of years, and the requirements we had in 2017, and they started rolling them out in the nuclear power plants, and we only start implementing them considering this cycle of the nuclear power plant. It's a huge phase that we're about to embark upon, and I will be showing you 3 options there. The fully fledged implementation of the measures with the subsystems of the nuclear power plant, that's the ideal option that we are trying to achieve, and I hope in a dozen of years all of the nuclear power plants will be like that. Or for example, if you do it at a subsystem, or for example, if you single out separate subsystem where you implement it, they make it safe without taking into account other subsystems, and there are some subtleties there, and I will speak about them more in detail. And the first one is the perfect option. There are some subsystems of power control systems in nuclear power plant with the preventive measures. All of the measures, all of the protection measures are used here, are implemented here. So we design the cybersecurity system. Why it's the cybersecurity? Because if we refer to the 239, Order 239, we have some specifics in terms of the communication channels and systems, and in order not to make anyone puzzled, we also speak about the subsystems of information security, which includes technical and organizational measures that are implemented in the process control system. There are some external and embedded measures like software, for instance. It's all covered with the organizational methods and some detective approach. When you deploy a special cybersecurity system, which takes this detective approach, which means that it detects, we detect the security events, we analyze them and try to react to possible incidents that may arise in the course of operation. Then we react and prevent such intrusions. Everything is covered again with the subsystem protection measures. Everything which relates to the perimeter is also covered. Either we deploy a demilitarized zone, DMZ, or we send the information through data diodes. Some systems do not require dense communication, so we can send some systems from process control system to the corporate system or elsewhere, and no other actions are required here. But sometimes we require access from the outer network, and we may arrange a DMZ when the process control system is separate on the diode level, and the system that acquires there will be a part of the DMZ, and it's connected via the firewall, and there will be some interaction conducted. And of course, we interact with the state security requirements systems. There are some other ways. When we have a subsystem which requires deployment, power, shelving, etc. So when we don't have a greenfield, but when we have an existing nuclear power plant, it would be very difficult to install this new system and power it up and connect it to other systems. Sometimes it's even impossible. So here we use just the preventive approach. So, for example, if the work is scheduled, if the construction goes on for 10 years, so there will be no changes implemented at all. So in this case, we implement a subsystem of information security, and all of the subsystems together show the complete process control system and its cybersecurity part. If we have an option of implementing a mini solution, will also include the CM and SOC, whatever. And also some organization is required here. Organizational measures are important. So it's not possible to build anything without them. The third option is more difficult. For that simple reason, if the power plant is running, you can put out of work some subsystems for a short period of time. For this, you'll have to design them for some time. You need to buy some equipment, and you just run this overhaul for a very short space in time to install new equipment and put it in production. It's not that possible to integrate all of the subsystems in one go, so you do it gradually. So you implement this separately and stage by stage. In this case, it aggravates the situation in the way that we put out of operation some systems as a separate unit. All the other subsystems possess a threat. If we take a previous option, you can consider it all together. So, for example, you should not use firewalls somewhere, or you should not use some antivirus protection. So I guess that's one of the most popular ways, because there are plenty of existing power plants and the rules and norms have been updated. So we mainly use option 3. And here is a set of compensation measures that are not required in the first place. Here we find them very important, like physical protection, industrial protection. So we measure them to the utmost. Let's just go back to option number 1. It's one of the most conceptual ones because we work on it, and we have 2 power plants currently at work. The Kursk nuclear power plants with 2 power units. There is a construction, and that's where we use this case. That's the first case that we use as a reference. Abroad, we have 2 projects. In Egypt, in Ildabo, there is a nuclear power plant under construction, and also in Patsha. So we don't just do it in theory, but we are implementing this in construction. And in every subsystem, we design and implement the cybersecurity system. We integrate the power control system, and all of the actions we take make sure that we are safe, make sure that they're safe ones. They have the specialized methods and portable ways. Apart from standard antivirus protection, sometimes you cannot install them, so we use portable antivirus measures. Last year, we worked with one of the major vendors of antivirus protection, and they had developed and certified special portable versions of antivirus protection. It helps us run them where it's not possible to run stationary antivirus, where it does not require to have usual checkups. So these portable ones are used there as a solution. There is an analyzer of a Wi-Fi traffic, control of the protection, etc. So there is a big, complicated system which is not just made out of the application part, but also of some other parts as well. What are the challenges that we are facing? There are plenty of them. Of course, I can dedicate the entire day to problems and challenges that we face. First of all, there are plenty of limitations that market dictates. And I guess this is going to actively develop because the choice of protection measures is limited for us. You need to check any protection tool in the system, and you cannot just do it once and for all, because software is proprietary. And therefore, there's a big variety of such solutions. So for every system, you just run a separate test and evaluate the influence, how it influences the system and how all of the updates influence the system. It does not relate to the security, cybersecurity, but it relates to the security of nuclear power plants. So you cannot just simply install an update in such a system. You should first test it. And these requirements are clearly stipulated, and only after the testing phase you can put it in operation. Not just sometimes during the operation, but sometimes during a shutdown period. So it's very difficult to consider, and each time it's taken separately. Firewalls. We know that we have some security classes, and all the equipment that we have is tested for seismological rigidity and stability, etc. So it's put into a rack, it's tested in a rack, and you cannot just embed any software or hardware in this rack. So you'd need to run a fully-fledged test on the prior phase. So during the operation phase, it is not going to be possible. So any software and hardware tool has a question of redundancy and fault tolerance. In the Russian segment, they do not accept Linux-based firewalls. However, in the foreign countries, it's considered to be as an alternative solution, but not here. We, anyway, try to test all of the tools just to minimize all possible risks and threats. And the number of the features required are necessary. We are testing lots of products, security products. We try to work with vendors directly, and as we test their products, we figure out that there are some mismatches in terms of their performance, productivity. Sometimes in the applied programs, we don't have any security tools, but we have a sufficient amount of corporate protection tools. But there is a very limited scope of those tools related to process control systems. And we just reveal this problem again and again. Then I would like to basically explain how we try to cope with all that. We mainly work with vendors and suppliers. Speaking in terms of software, we try to set the requirements right for the embedded security protection, security, cybersecurity. So we've already introduced the SCADA systems. This process is a long one, and of course this cycle is an endless one, but it actually influences the quality of the product. The quality of the product has grown, and it affects the availability. So if the software does not stand the fuzzing test, then we should not be speaking about the product rigidity and reliability. We have the embedded tools for the operating systems, and we are testing software tools, but there are some difficulties there. I've spoken about taking into account the portable systems solutions. I've spoken about that. We also give feedback to the vendors about what the mismatches are, and we established very good partners relations with our vendors, and they fine-tune their products, removing all those mismatches, and that's how we implement the antivirus systems. All the software and hardware tools are analyzed before implementation phase. Sometimes the vendors, which are shown everywhere, are shown on the internet. So that's what we need to accept. Like, for example, remove wireless interfaces. That's the basic level of security. It already removes quite a lot of potential threats. If we take a look at the software level, apart from the big number of additional systems, we have CM systems, we have SOC, we have antivirus protection and additional solutions. And of course, process control systems for nuclear power plants is not just hardware and software part. It's a lot of organizational work as well. So if we don't imagine what would be the damage from a certain attack, if we don't understand how the personnel reacts to that, to a computer-based incident, how to follow it through, then we wouldn't be able, with an assistance of any software tools, to guarantee any level of cybersecurity. So I think organizationally, we just take 60% of all of the measures that are applied at nuclear power plant. Organization takes for 60%. We are currently finishing the implementation phase of cyber test site for testing the cybersecurity process control systems for nuclear power plants, and they are tested there in the conditions which are close to real ones. We test process control systems, we do pin tests there, we train the staff, that's the organizational training that I mentioned previously. Trainings are important because otherwise, without them, it's all monkey business. In terms of the resource support, we have bought some modules that are required there. The modules of the top unit level, the system of normal operation, emergency protection systems, and process control systems of the nuclear power plant is also there. And the most important thing is the module of the accumulation of the simulation of the computer attacks, and how the valves and turbines actually act in case of such a test. And it actually looks like this. So we are planning on releasing it in the upcoming months. So we are finishing the test, and it's going to be Moscow-based on the Ferganskaya Street. So if we have some equipment arriving that requires the necessary modules connection, we do all the necessary tests. Otherwise, we'll just measure the vulnerabilities, or we run the tests of the protection measures, and this combination with other systems, like, for example, take a look what the reaction will be and how it will affect the performance. We will be testing it there at that test site. So I think it was a very quick run through the slides. I've tried to explain how we do it in nuclear power plant business, and I hope it was interesting.
Все, тогда, если вопросов нет.
I think we are done. No questions then.
Добрый день, Людмила, спасибо за доклад.
Hello, Ludmila. Thank you for your presentation. I'm Daniil from Rosatom.
С какой периодичностью и как
How frequently
кибератаки, которые
do we have these cyber attacks, and what are they targeted? If we take nuclear power plants as a target, what's the main target there for these cyber attacks in case with the nuclear power plants? I'm highly unlikely to share anything statistics with you. I think it's all standard story, because it starts with amateur hackers to more serious ones, because these are the key infrastructure facilities. If you put down, if you shut down this plant for a few hours and some units will shut down, you will cut the power for some regions. So I think it is considered such attacks are masterminded at a higher level than amateurs. So here's the question. You are supplying to Brest. Yes, but I'm actually in charge of the nuclear power plants of lower capacity, and we are currently running this project. So we would like to make sure that nuclear power plants have no operators, so they would be lights out facilities, completely automated. So we run experiments. That's very interesting. So I hope we'll work together with you and you will help us with that. Okay, I'm leaving the stage, and thank you very much for your presentation.
Вы рассказывали о том, что необходимо оценивать влияние
IT systems company, you said that we need to monitor the influence of how they influence the system, and how do you evaluate them?
Ну, у нас две стадии
We
происходят.
have two stages.
Они сейчас в активной составляющей. То есть первое это на проектных решениях.
First one,
То есть изначально
project
расчеты
solutions.
ведутся, то есть происходит
We
анализ
make
надежности.
calculations, we look at how reliable
Сотрудники наши, которые занимаются
system is, and our colleagues,
и по
and
своим методикам это проводят.
they look at the reliability of the system based on what it is, and then so we do it autonomously. First, we look at the performance of it, so if it meets our requirements, and then we use working models that our vendors have, systems that are not mass-produced yet. So we implement them and we run them on simulations. We see how they work in the emergency situation and regular work. So how this device would work. If we're talking about some software or antiviruses, so the same principle. So we check them in different modes of work. We do it in the test site and the cyber test site, and we also have in Sarov City we have a test site, and they ensure security on the level of software. So we have this test site. So they install the software, they imitate, simulate all possible situations for the software and how to say antivirus behaves. And what's the length of those tests? Months? Well, actually, it depends on the components and how loaded we are. I mean, the equipment that we use. The latest test we had, it was few months for antivirus and only for one system. Yep, thank you.